everyone. So I'll continue my the discussion from the last video. So last video I already talked about the gravitational potential. What is potential? And I told that my intention is to calculate the gravitational potential for a particular point due to a solid sphere. Why solid sphere? Because Earth is a solid sphere, correct? So we will gonna my aim is to calculate the for a solid sphere, like the gravitational potential. So this is a solid sphere. Okay, I have a solid sphere like this. This is 3D sphere, correct? Not a circle. So solid sphere. From the center I have some point P, which is r distance from the center, and I calculate that point P what is the potential. Okay, and how I'll achieve to the solid sphere, because now I'm going to use some of the mathematical techniques called integration, correct? What is integration? So I know, like you guys, like who knows calculus, or who is learning calculus, or do know calculus, but you heard about the name like integration or differentiation. They are very they are very it name like integration. People, if they listen hear about the name of integration, they'll very scared, correct? Like what is integration, what is differentiation? But when you learn the integration in proper way, you will love that. Integration is not about the formula, like it is not about the formula. You should know what is the basic behind the integration, because integration is the very powerful technique in mathematics. Not only integration, even differentiation, through which we can solve lots of real-time problems very easily, correct? Suppose I have some problem to be solved, like this problem, like for example I have a big problems. So what I can do, I can make the problem very small pieces, cut the problem small pieces, then I can add all the problems together to get the solution for the final problem. So what I'm doing, like I'm just problem, I'm just breaking the problem in small pieces, calculating the solution for the each pieces, then I'm integrating all the pieces to get the solution of the whole problem. That is integration, correct? That is the overall idea about the integration. So here we'll apply integration to calculate the gravitational potential of a particular point due to a solid sphere with mass m, correct? How we'll achieve there? So we know, suppose now I am assuming you know the gravitational potential of a point P, which is r distance away from the point mass, and we know the gravitational potential for that, correct? We have a formula. We can derive that formula. We'll derive when we'll have a formal section wise class. That time we will derive that, like it is my g m by r. So m is a point mass here. You do remember m is a point mass, correct? Okay, now from this point we know this, correct? So how we'll make a sphere from a point mass? Okay, now what we'll do, I will from sphere can be made using the small hollow spheres, correct? One solid sphere can be made from the small hollow sphere. If I keep adding the hollow sphere like this, I can make a big sphere, correct? I can make a solid sphere. So that means what? I am just creating a small hollow sphere. So if I can calculate, suppose I have a hollow sphere, and if I can calculate from the center of the hollow sphere from particular point P, what is the gravitational potential due to this hollow sphere, then if I can calculate for the one hollow sphere what is the potential, then I can integrate all these hollow spheres and the potential for the particular point for all the hollow sphere, and then I can come up with the potential on the particular point due to the solid sphere. So here what I am doing, I am keep integrating the hollow spheres, correct? Now how will calculate the hollow sphere? Like I will, okay, hollow sphere I can create. Suppose this is a hollow sphere, correct? Big hollow sphere. How can I create the hollow sphere? I can have a small ring, correct, like that. So this is the hollow sphere, this is the center of the sphere, correct? What I can do, and this is the point P from the center, r distance, I can create a small ring. Okay, divide this hollow sphere in a small ring, correct? This is a ring, correct? Like you can see that this side also we have this dot, and this side you can see, this side you cannot see, this side you can see, you can not see. This is a small ring, correct? I can create a small ring, and I can make a hollow sphere. So that means infinite ring I can just imagine, and that ring I can place one by one, I create a hollow sphere, and for each ring I can calculate the potential at point P. then I can add all this potential, correct? And potential will not have a direction, correct? It is a scalar quantity already discussed on the last video. So very simple, correct? So what we are doing, we are integrating to getting a one object, we are integrating that, we are getting that object using integrating other objects, and we are picking the objects to like which is easy to like put one by one getting the full object, correct? Full like a so from the ring, from the point mass I will get the ring potential, correct? From the point mass, then I will from the ring I'll integrate the ring, I'll get a hollow sphere. From the I integrated the hollow sphere, I'll get the potential of a solid sphere particular point. Okay, now let's calculate. So we know the potential for a point mass, that is nothing but the if a point mass is m, the potential of particular point is nothing but the minus g m by r. So that derivation will come when we will do the formal class for the gravity. That time we will derive that, like it is and it is coming from the definition only. It is like the negative work done for bringing a unit mass from infinity to particular point p, work done by the conservative force, here gravitational force. Got it. Okay, now we know this for the point mass, the potential at particular point which is lie distance r from that point mass, correct? So r is a position vector, and this is a scalar quantity, so there is no direction. And why negative, correct? We already discussed why it is negative, but just imagine this guy, this m is a bank, correct? On the finance, because I work in finance, so finance perspective, correct? He has the money at particular point, suppose particular point he can lend this much money to someone, correct? So when you want to lend that particular point p, lending means this is a negative cash flow for him, and someone will come m mass, okay, and he will grab that loan and he will use for him it is the coming as a cash inflow for him, correct? For him it will be positive, it is a potential energy for him, correct? He will get energy from this guy. So potential at particular point p is the negative, because this is the he want to lend that, correct, to someone. Come, please come and take that as a use that as a energy for yourself. Clear? Okay, now let's draw a ring. How it looks, let's see. If I draw a ring, I'll insert a shape here, a ring, correct? Okay, now I'm drawing a ring here. Got it? Okay. So this is the center of the ring. Now my objective is to calculate the potential at point P, which is r distance from the center O, and I have to calculate the potential of that point P due to this ring. Ring is a this is a ring, and all the masses are distributed on the perimeter of the ring, correct? Like if I draw the ring, like small ring like this, correct? So this can be a ring, you can imagine, correct? This is a ring. Okay, I can make it as a slightly thicker. So this is a ring, correct? Okay, so this is a ring, and here all the masses are accumulated here only on the perimeter of the ring. Okay, now what I can do, I told that I will from the point mass I will create a ring, correct? So what I do, I will just create a small dm from the ring, correct? I can create small dm, infinity dm, okay, throughout the ring, and dm is very small. So in physics everything very small will represent it with the d, small d. So dm is very small, it is like a dm is tends to 0. So like for example, this is dm, this is dm, and all the dm if I add, like dm plus dm if I add, we'll get it as a whole mass of the ring. So this ring mass is m, this is r, like the radius is r, capital R, mass m, capital R. Okay, now what is the potential at particular point, okay, due to this ring? How I calculate? I know the potential for a point mass, correct? This is I know only potential for a point mass. I don't know the potential for a ring, because mass is distributed here on the perimeter. So what I'll do, I'll take one of the dm. You can take any dm, I can take any dm, correct, from here. Then I will calculate the distance between these two dm and the point P. So gravitational force or working between the axis joining between the 2 points, correct, like this way. It cannot come from this way, different distance, correct, between joining the 2 points. Now what is the distance between dm and P? This is the distance. This is called, for example, I am taking it as a z. Okay, now as per the Pythagoras theorem, I can see that I can write that z square equal to r square plus r square, correct, or z equal to r square plus r square. Okay, and if you think a ring, suppose this is a ring, I'm just drawing the ring. Why I'm drawing it like that? Okay, now this is the center of the ring, correct. Now I'm drawing a axis which is passing through the center of the ring. Now from particular point P, here I'm calculating. See, here I place the ring in a horizontal way, correct, here in this picture. Now if you take the distance everywhere from the ring, correct, like this distance, if you see, this distance is always same, correct, from this point. Just imagine this is a tent and I have a pivot point here, okay, where I'm suppose these are the ropes, correct. So all will have the same distance from the ring perimeter, correct. That means wherever you cut the mass, correct, dm, wherever you cut the mass, from here the P distance will be always same. So z is fixed here, correct? G is not changing. Now what is the, now I'll calculate for the one. So I calculate the small potential dV, okay, due to the particular dm. What is the small potential? Because dm is a small mass, is a point mass. Now I can directly apply the formula minus g dm by z. Very simple. Okay, now then this is a small potential for a small dm mass. Okay, dm mass is nothing but the small mass I have taken, because I cannot consider a ring, because I know potential only for a point mass. So I created a point mass dm. Now what is v? Nothing but the integration of dv. I am integrating all this potential. I told potential scalar quantity, I just simply add it. Now I am getting minus of integration z dm by g. Okay, now you see here g is constant, z is constant, correct, both are constant. So I don't have any variable here. So what I can do, I can do g, and what is the dm? If you add dm, it will give the m. So integration of dm. So v equal to integration of dv equal to integration of dm of minus g by z. So it will nothing but minus gm by g z. So that is the potential of a point which is lying on the axis passing through the center of a ring by a uniform ring is minus gm by z. Okay, so I can say in the z, I can convert it to the minus gm by root over r square plus r square, correct. I can do that, correct. So if I know the if something, some object, some point which is r distance from the center of a ring, then I can calculate the potential of the ring is nothing but the minus gm root over r square plus small r square. And I know like you guys already know these formulas maybe, okay, but I'll just show you how to derive that formula through the integration. Okay, so this is the potential at a point for a ring, uniform ring, which is lying on the center of the axis passing through the center of the ring, and r distance from the center, like small r distance. Okay, so next video we will now integrate ring, will one by one ring will place and will create a thin shell and calculate the potential of the thin shell. Thank you guys.